Hello, my name is Kayuka Holoa, and my project is carbonic anhydrase in corals. The reason I chose this project is because I'm passionate about preventing coral bleaching, and I would like to solve this problem by looking at how we can manipulate things on the molecular level. I'm also conducting research this summer on corals, and hopefully I can look at it through enzymes such as carbonic anhydrase. So to begin, coral need to calcify in order to house symbiotic algae. These algae can provide up to 90% of the coral's energy. Carbonic anhydrase is an enzyme that is able to interconvert CO2 and HCO3, which means that it can turn carbon dioxide into bicarbonate and bicarbonate into carbon dioxide. This is very useful for both the algae and coral because the algae is able to use the CO2 to photosynthesize and the coral is able to use the CO3 to calcify. This led me to my research question, which is by increasing the enzyme activity of carbonic anhydrase in coral, can we also increase their calcification rates? Oops. Here are some infographs, where this image shows that an increase in free hydrogen ions, which also means a decrease in pH, causes fewer carbonate ions because they're getting protonated into bicarbonate. This also causes corals to not be able to calcify because there is less carbonate for them to utilize. This next image is very important because it shows how often carbonic anhydrase is used within the coral. So, like I said earlier, the enzyme is converting bicarbonate into carbon dioxide so that the algae can use it. And as mitochondria respire CO2, carbonic anhydrase converts it to bicarbonate. Sorry. Sorry about that. But as carbon dioxide is respired from the mitochondria, carbonic anhydrase is able to convert it into bicarbonate so that the corals are able to utilize carbonate in creating more skeleton. This image shows that as carbonic anhydrase activity increases, so does the quantity of proteins. And this image shows that carbonic anhydrase is located or is concentrated at the surface of corals, which makes sense because this is where the algae lives and where new skeleton is being formed. So in future research, we would want to focus on the surface of the corals. This connects to biochemistry because biochemistry is the study of chemical processes within and relating to living organisms. Carbonic anhydrase is an enzyme, and enzymes are able to catalyze biochemical reactions. So, after further investigation, I found that an increase in the enzyme may not necessarily provide an increase to coral calcification rates. This is because the enzyme creates bicarbonate, not carbonate, and corals misuse the carbonate to create to calcify. So what corals have to do is they have to deprotonate this bicarbonate into carbonate, and that uses a lot of energy due to the increased concentrations of hydrogen shown in the previous image in the surrounding seawater. So unfortunately, my research for this project was focused around the wrong problem, but it's okay because it led me to a new research question, which is there an acid-base catalyst that can help corals deprotonate bicarbonate? So if there is a acid-base catalyst, then we would be able to separate HCO, the hydrogens from the rest of the CO3. Sorry, there should be a 3 there. And then that could actually help further that could further help corals calcify, because then there would be more carbonate ions in solution. But such a catalyst would probably need to survive physiological pH while also causing no harm to the corals. Intellectual merit. Investigating this research question can lead to a new method of solving molecular problems through the manipulation of enzymes. Broader impacts. This proposed research could benefit society by preventing corals from bleaching. This research can also potentially be used in many other problems in which enzymes could provide a hidden key in solving, such as those as the medical field. If you figure out how to manipulate enzymes, then I feel like many other problems out there, such as those in medicine and physiology, could have a better chance of being solved. These are my works cited, and thank you for listening.